All right, let's do a little trickier example of finding zeros of polynomial functions. Now, you'll notice we have a degree of 5. That means we're looking for 5 zeros. So I'm going to plug it in my calculator to find my easy zeros, and I'm going to go look at the graph. And you'll see this is a bit crazy. I'm going to zoom in a bit. I want to see what's going on right there. It looks like I have 1, 2, 3. I can't tell if that is crossing or touching and turning back around. And if you remember multiplicity, if it's touching and turning back around, that is a zero, a repeated zero. And so we'll want to write that one down twice. I'm going to zoom in just a little bit and see what I see. And yes, it is. So at -1, it looks like, if that is a zero, it looks like a repeated zero. And then, so we're going to count that as 2. And I don't know, I can't quite tell what's going on here. So I'm going to go to the table. So, okay, -1 is a 0. So x equals -1. And that one looked to be a repeated 0 or have a multiplicity of 2. So I'm going to write it twice because it has a multiplicity of 2. And I see 3 is also a 0. So if all 3 of those are zeros, then I will be able to bring this down to a quadratic and then use the quadratic formula. So let's give it a go. We're going to start off with synthetic division. And we have 5, 4, 3. We do not have a squared term, so we're going to need a placeholder, 1 and our constant. All right, so let's set it up. X to the 5th has a coefficient of 1. This is -1. This is -8. We're going to leave a 0 for our x squared term, +15, and +9. We're going to bring down our first term. And we need to put a 0 out here. I almost forgot. We can choose any one of these we want. It does not matter which one we start with. I wrote -1 first, so that's the one I'm going to start with. And I'm going to say 1 times -1 is -1. And I'm going to add down and I get -2. -2 times -1 is +2. I'm going to add down and I get -6. -6 times -1 is +6. Add down and I get 6. 6 times -1 is -6. Add down and I get +9. 9 times -1 is -9. And we get a 0 remainder, which is good because it's a 0 that we found in the calculator. Now here's where we're going to find out if that -1 was really a repeated 0 or not. We're pretty sure it is. We're going to do synthetic division again, and we're going to use the second -1. So I'm using this guy. I've already used that one. Now I'm using this one. And I'm going to bring down the first term, and I'm going to start again. 1 times -1 is -1. Add down, I get -3. -3 times -1 is +3. Add down, and I get -3. -3 times -1 is +3. Add down, and I get +9. 9 times -1 is -9. Add down, and I get 0. And you'll notice it divided evenly in again. So we know that that was also a 0. So we've used these two. And now it's time to use the last 0 we found in our calculator. So we're going to use this 3 this time. So we're going to bring down this one more time, and we're going to put a 3 out here. Bring down our first term. 1 times 3 is 3. Add down, I get 0. 0 times anything is 0. Add down, I get -3. -3 times 3 is -9. Add down, and I get 0. So our final quadratic is right here. Now I could use the quadratic formula if I wanted, but whenever you have a missing term in the middle, you don't really need to, because the polynomial that you get right here is x squared minus 3. There is no linear term. And if you have trouble figuring out your degree, you have two options. You can start up here at where you started and subtract how many times you've done synthetic division. So 5 minus 1, 2, 3 will give me 2. Or you can work backwards from your remainder. This is your remainder, constant, x to the first power and x to the second power. So if we have this and we set it equal to 0, all we need to do is add 3 to both sides. So x squared equals 3. Take the square root. And don't forget that there should be two answers. So x equals plus or minus the square root of 3. So list all your zeros, plus or minus the square root of 3, -1, -1, and 3. If we needed to write this in factored form, we could. We would say x plus square root of 3 times x minus the square root of 3 times x plus 1. And this has a multiplicity of 2. And then x minus 3. So this would be our factored form of this polynomial function.